Hello everyone. Today we will present our project titled Analysis of Early Alzheimer's Disease, conducted by myself, Rahul Sajit, and my teammate Shubham Tiwari. The primary objective of our research is to explore and evaluate various ML models and techniques to accurately classify patients into three diagnostic categories, namely cognitive normal, mild cognitive normal, and Alzheimer's disease. Going to the data overview, for our analysis, we used the OSS1 free surfer dataset, which comprises of cross-sectional brain MRI data from 416 subjects aged between 18 and 96 years. About the data preprocessing. So, initially we merged the OSS1 free surfer brain imaging data with relevant demographic data using the unique subject ID. We then performed data cleaning by dropping unnecessary columns such as subject ID, diagnosis, CDR, gender information, and handedness. Given the inherent class imbalance in one dataset, we applied the synthetic minority oversampling technique to balance the data set effectively. This set this step significantly enhanced the robustness and reliability of our predictive models. Lastly, we encoded our target labels using the label encoder and divided the data into training and testing subsets for model evaluation and validation. Now Shubham will take the presentation forward from here.
Thank you, Rahul. So for basically we use three models. Those are Random Forest, XGBoost, and 1D CNN. As you can see over here that we have used Random Forest uh, and we have divided the data. And this is the following result we have gotten from that. As you can see that F1 score for the cognitive CN that is 92%, and for AD and MCI is like about 50 but below 60. It indicates that it has performed good on the CN but moderately performed on the AD and MCI. Given that our data was imbalanced, it might be one of the problem. Next, as you can see, these are the top 15 features. The features important analysis provides medically relevant insights about which brain region are most affected in early stages. And this is our XGBoost classifier. Take a closer look at the XGBoost classifier result. You can see that same over here, the CNAs perform better than AD and MCI. But overall, the XGBoost has performed much better than Random Forest, because if you take a closer look at Random Forest, it didn't perform that good, but CGI did perform very good. Apart from that, there we also went and go ahead, we went ahead and uh, predicted it on the demographic only. Results shows that demographic features alone provide less predictive power compared to using brain region measurement, highlighting the importance of neuroimaging data in early diagnosis. After that, we performed the same models on the smart data. Uh, After performing it on the some smart data, you can just say that the data did perform well on the minority classes such as AD and MCI. By we basically created synthetic simple samples for this one. Same goes with this. This is the comparison between the before and after the analysis of the data. Okay. This is for the XGBoost, that was for the Random Forest. Even for the XGBoost, it performed very well for the ADA, MCN, as well as CN. For CN, it went till 97% after using smart data, but before that, it was like 94%. Over here, if you take a look over here, it's 94%. And after that, we performed the one day CNN. This is our 1D CNN model summary. This is our following layers, and if you take a closer look at this, dense with a ReLU is our most complex layer, as it's going with the 106 parameters. And this is our training history, and this is our testing. You can see that it gave us 82%, indicating that it did perform very good, given that it was an imbalanced data set, because we used the imbalanced data set for the first one. And the overall accuracy, if you look as per the classes AD, CN, and MI, the CN also did better than AD and MCI. The MCI although did a moderate performance, but not AD. This is our learning curve. If you take a closer look at this, blue is rising steadily, indicating that it's learning effectively. But if you take a look at the validation accuracy, it's indicating that there's a overfitting in the data set. This is our model with the balanced data, that is smart data. And if you take a closer look at the result of the smart data, the accuracy on the test set is 84%, which is really good because we received 82% without the smart data. And if you take a closer look at the learning curve is the training accuracy is increasing increasing and stopped after 10 epochs, indicating that it has learned really good and there's no overfitting in the data. And this is our result of the 1D CNN with smart data. You can take a look here. There's not much difference between the CN in 1D without the smart and 1D with the smart. They are this same 93.75%. This indicates that the total overall performance, if you take a look at the overall performance, the XGBoost with smart data, it did very good in going with the performance. This is our best model as per the classes. If you take a look at the all classes AD, CN, and MCI, XGBoost with smart performed the best among everything. This might be because of the classes which is given the distribution of the data is the CN is most distributed than anything else. Thank you.
Thank you.